Maybe. Let's make sure all is good. I'm unmuted. We are streaming. MLH is live on Twitch. So here we go. Okay, so let's make sure I've got everything pulled up. I'm pretty sure I do, but I was doing some last minute research. But it is day 3 of Global Hack Week. How are things going? Let's see if there's anyone in chat. Probably not. That's fair. This is a pretty low-key stream. And while I'm at it, let's go find the event link. So I have that. There is no word from chat. I can only assume I'm muted or things are horribly, horribly wrong. It's also terribly quiet, so headphones make more sense because then I can play music instead of sitting quiet waiting for chat. Let's go grab that really quick, actually. I have too many windows open. That's a me problem. Ah, there are people. Hello. It is still too quiet though, so music for me in the background. Cool. And people are coming in the chat. Yay. Good. That means I'm not talking into the void. I mean, if you're watching this as a recording, like, that's fair. I'm busy too. Ooh, lots of people from this morning's Today in Global Hack Week. Did y'all take a break and get water by chance? Hopefully you have. I hope to time this so that way you get like a 5 to 10 minute break to actually do that before more streams kick off for the rest of the day. But let me go ahead and add our to-do list for today and zoom in some more so that way we can get into today. So this will only be like a 45-ish minute stream, even though it will be chock full of information, very much theoretical, but also applicable, just like not much prototyping going on. But I think it'll still be pretty helpful for anyone doing AI, machine learning, computer vision, etc. projects that require a lot of data. Oh, now y'all are here. Hello. So active now. Getting over that shyness, I guess. Gotta beat the stereotype of computer scientists being shy. We are very functional beings and we can learn how to socialize. And it varies from place to place. Okay. But yeah, so if you have never been to a stream before with me as your host, generally, at least like when I'm doing stuff, we always break things. And the goal is to try and break things less. But also for context, I am a PhD student studying hackathons. That said, I have a lot of experience in like how do you learn and like what are we gaining from things. But I also have a lot of experience in other research topics like computer vision and semantic web, and like just generally like I read a lot of papers. So I gain a lot of passive knowledge on top of being like a software engineer and technologist. And so my hope is that at the end of the day, you get something out of these streams, whether it's that you learn how to debug or you learn how to like think about a problem differently. Whether or not we successfully do the project, if there is a project, is a completely different goal that we almost never reach. But that's okay, because it shows that these are very natural live streams in the sense that I'm like actively trying to fix things, and showing that like anyone can work under pressure. But caveats aside, welcome to those that are new. If you've been to one of my streams before, you know that I encourage people to be community members and helping each other out, whether it's like, hey, I'm having an issue, you're posting it in chat that like to help me out, or that you are helping a community member out because they're also having trouble and maybe I haven't seen the chat or I just don't have the answer. And the reason I mention that is that even though I know a lot of things, I also don't know a lot of things. I'm a little behind technology-wise because I spend most of my time doing my PhD, which is also why I do these streams with the intent of trying to learn new and current technologies. But there are, again, concepts that carry on despite that. I am a developer. I'm doing okay. It kind of feels like Friday, even though it's Sunday. It is Sunday, right? It is Sunday. Okay. Be that kind of week. Alrighty. So let's get into it. I've killed 5 minutes already. Everybody who's here that wants to be here will still probably be here and should be here so we can get started. So I always do these to-do lists for our streams because I get off track. And I'm pretty sure chat likes to take me off track, and that's fine, but I do want to make sure people come away with something. So I've mentioned in Today in Global Hack Week that we're looking into like how do you critically think about data sets that you want for your project. Also, quick check. You can hear me okay. You can see this okay. If you need me to like zoom in or like talk louder, let me know. Because I want to make sure that people can hear me, especially if like there are disabilities at play. I can't provide closed captioning, but I wish I could. But I do try to make sure that people can see and like hear it and whatnot. But all of the I do anything and everything. I don't have a specialty. My specialty is just learning stuff, which can be counterproductive at times. Anyway, so I brought up a ton of links about where to find data sets. Because there are so many places. And that has changed over the years. There's now even more data out there. Great. But what do you do with all of that? Because that can be pretty overwhelming. Like you can see there's a ton of links that you could search at any different time. And if you are in a different country, there's a chance that your country also has a multitude of different links or places to find data. So you'll see that I have like the UK, I have WHO, which is the Global Health Initiative and Observatory and whatnot. Then we have like NASA. So chances are your own. Oh, zoom in. I can do that. We'll see if Google will let me do that. Let's do 3. Nope, that didn't work. Okay, let's do it this way. I can't zoom in anymore. Let's see. Is there a better way for me to... You know what? Let's change the font size. How is that, Jupiter? I've made this quite a bit bigger. Can make it even more... I could put it like at a really ridiculous font size, but I do want to not get too far off track. Again, I am very good at getting distracted. Anyway, there's tons and tons of data sets out there. So, I mean, everybody who tends to get into the data science side of things, AI, machine learning, etc., always end up at Kaggle first. And the reason they end up at Kaggle is that it's a really popular site to like challenge yourself and learn all sorts of things, whether it's that you want to compete. Let me zoom this in as well. So let's say you want to like compete or you want to use models that people have trained. You want to see how other people have used code. This is a great spot to get started, but I mean, there's a little bit of barrier in that aspect of like, what if you don't know what you're looking at? What if you don't know what to do? So we're going to start today with just like the data sets part of it, because that's what this workshop is for. Fun fact, I don't do slides. I just don't. I only have a to-do list usually, which is this mess. So this is something that will come back to you throughout it. But there's no slides. There's only the recording that comes out afterward. Okay. But dataset wise, right. So we could search anything. We can see all the trending ones. We can see who's made it, when it's updated. And obviously they all have different files. Some of them tell us it's an other. Some of us tell it's CSV. There's ways to vote for the validity of things. But I mean, much like you would say a book or a Twitter account, an X account, or Facebook or other aspects that you use, you were probably taught or advised to like think about it. Do you know this person? For like Facebook before you add a friend, or like LinkedIn. Do you know, have you like truly met this person? Or you might say like, when was this like library last updated when you're coding? Or, hey, like how many people are using this library? And these are similar thoughts you can use with your data sets, where you can ask yourself like, how many people are using this data set? How many people have voted for this data set? And do you think that people have just jumped on voting for this data set because everyone else has? That's a new thing to consider, especially when you consider like the like button and a variety of other things. There's also, of course, different topics like LLM fine-tuning, universities and colleges, Earth and nature, the Titanic data set. No idea what that means. We'll find out, though. But there's all sorts of different data sets that people have created, which is amazing, even though the human labor behind that can be quite intense. So when I first started doing research in these areas, before I switched to the research that I'm currently doing in my PhD, we had things like Amazon's Mechanical Turk, which was a way to help label data sets to create these monstrous things that everybody's using now, like transportation and like delays in the Deutsche Bahn. Oh boy, I'm very curious about that one actually, because it's quite delayed. But the point is like, there's all sorts of data. And there's a lot of people uploading things, but how truly reliable are these? So let's take a pause at Kaggle and let's go look at some of the other ones. So we have NASA. We have the Open Data Portal. When it gets there. It's thinking about it. There we go. Okay. So let's say you want to work with the Mars images, you want to work with moon data, whatever. Let's go look at what they have. The difference between Kaggle and NASA or some of the other more like government related data sets is that there tends to be a lot more, I guess, oversight is a word that I would use, in the sense that these projects have been planned for years, decades, even in some cases, with like very distinct things that they're looking at, which often have a lot of real world implications. Or if you're more interested in the science aspect, that you can actually like use current things and then talk about it, especially if you're looking for jobs in science fields. That gets into like scientific development, which I can talk about later if you all have a question about that. But the point is, if you are coming up with a project, thinking about that data set, what kind of data set do you want? What's your project going to impact, if anything? It doesn't actually have to impact anything. It doesn't need to change the world if the goal might be just changing you and learning what you need. But you can see there's all these really complex titles. I don't know what any of this means. Something about the Tropical Pacific Field Campaign. But they're giving us details more so about like what it's been used for, where it's been published. It looks like they have screenshots, how they should be used, and what they show about rainfall. They have a link to the publication. Love that. It's talking about salinity processes and the Upper Ocean Regional Study Project. Cool. So oceanographic research is actually really important. I mean, it's like what, 70% of the world is water or something? Or is oceans? That might be a wrong number. Don't quote me on that. Oops, zooming. There we go. So the point is, there's lots of scientific data out there that's just been generated by all the different missions being funded by, say, NASA. And once again, let's go ahead and open another thing. Let's go to the UK. So the UK has also sources of data. I don't want analytics on me, thank you. And zoom in, where maybe it's like we want to add data if you're in the UK and you want to add stuff in. But different than Kaggle, it's that there's a lot more background involved in it. And you can also request data from what I understand. But they also have like, if these tutorials or like how students can access it, there's tons of resources. So you are now overwhelmed with data sets. Now what? Well, again, thinking about a project, let's say I'm a new data scientist. I don't know what's out there. I just know I need data. I need to do something with it. What can I do? And again, there's plenty. So let's take for the perspective of COVID. During COVID, a lot of people got into data science because they wanted to give back. They wanted to help. They wanted to make sense of all this data that was coming in worldwide. And so maybe it's that you want to just create maps, like graphic design, or not graphic design, like charts. Or you wanted to plot data and see the trends for yourself. Or maybe you wanted to convince your friends and family, like, hey, this is a problem. Like, this is why you should wear a mask. Here's the like infection rate or something. All sorts of things. Whether you choose to wear a mask or not, I'm not here to judge. That was just an example. But the point is, there are different ways you can use your data. So you might also think about like, well, what's the story that I'm trying to say with the data? Maybe it's just that I'm trying to do mathematical references and charts and whatnot. In which case, the story is what's going on. What are the trends? Maybe it's that I want to use that model to predict something else. So in this case, maybe like, what's another one? I'm just skimming. I don't know what that means. Okay, it looks like this is more about wavelengths. I do have some baby little knowledge about it. But maybe it's that I want to actually do like go through the labeled data enough to predict the appearance of some specific thing that's labeled already. This is really popular in science instrumentation with regards to astronomy or like different wavelengths, of course, and different like wave bands where you want to identify weird things, let's call it that, also known as anomalies. Maybe it's that you want to label the data, or maybe the data is already labeled and you want to just say like, hey, given another layer or wavelength or some other form of incoming information, how do I flag it for review for scientists? And that's a very real project that exists all over the place. Scientists are getting petabytes of data, and they're only human, and there is just not enough humans in the world much less humans that are trained to look for these kinds of things, that they would be able to sift through all the information, find those anomalies, and make the scientific discoveries we love hearing about, like the black hole being captured. That was petabytes of data. You saw how many hard drives they had. So there's ways that you can, again, identify or predict other things. So somebody actually mentioned this, and we're going to come back to this. I'm going to go find Kaggle again. But they kind of realized that the data sets on Kaggle can't really be used too much for real-world applications. They're more for quote-unquote projects, which excellent comment. This is exactly what I was going to be getting at, and that's the main point of the stream, which is that think critically about data sets. When they're coming from a reputable source, such as NASA or any .gov site, chances are they're real. And if you're not sure if they're real, go read the paper. And if you can't read the paper, that's okay. I'm sure ChatGPT, there's someone who's made a ChatGPT extension of like, summarize this paper for me. Don't use that as law, like go back and reread the paper. But there are many ways to interpret information. Which is to say, if you're on Kaggle, how do you make sure what you're looking at is like actually useful? And the best way to look into this is actually to look at biology sets. Biology data sets tend to have the most simulated data because we can't always capture everything. So right off the bat, you see a couple things that haven't been updated in a couple years. But does that mean that these things have actually changed? And so we have a rating system of like, hey, it's like a bronze data set. That means it might be pretty useful, even if it necessarily hasn't been updated. Maybe because they haven't retrieved new data. So there's a multi-label classification of enzyme substrates. I have no idea what that is. Let's go look at it. Multi-label classification. Okay, if I was doing a classifier project, that would be great. And if you're staying on for Steven's stream, maybe you can ask him about this data set and see what he thinks about it. But they already tell you that they're never expected to update, which means they probably finished collecting data and they don't need to collect more, or there's just not going to be a repeat of the experiment. So they've captured what they could. Then you have what other databases or licenses. Okay, great. That means there's other places that this was found from. If we wanted to click it, maybe we'd know more about like what the license is or where it's from. They've tagged it as business, which I guess is interesting for enzymes, unless it's like a medical business aspect. Biology, tabular, deep learning, blah, 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 blah. All sorts of things you can use it for. So we're like, okay, project-wise, how do we think about that? They give us a couple different files. They tell us about the files, which is awesome. We love that. We love that they've told us how to use it, which means it's a data set that was made with care. And so we're seeing that like, hey, there's a huge label and class imbalance in the data. Like, what does that mean? And the way to investigate that is actually to download or look at previews of the data, or maybe they've explained better. Like, what do you mean there's an imbalance? Is it that there are mislabeled things? Is it that there's too many labels and not enough classes, or vice versa? There are many ways in which like you can look into it. But as you can see, there's like a preview. It gives us like a range of like what things are, whether we understand it or not. We can see that this is a pretty nice data set. It gives us a lot of information. Compact version, none of the statistics about it. Okay, I don't know what I'm looking at realistically. It also tells us more about the columns. Okay, so it looks like they've classified a lot of things. They've given us some more data set information. On your own, say in the government data sets, you might actually have to do this yourself. You might have to go like, what is the range of what I'm looking at? And so this gets into more like, okay, you found a data set, you think you like it. Like, what does it all say? What's like a preliminary idea of what you're looking at? That's called investigating descriptive statistics, which is what this page is doing. It's giving us descriptive statistics that we might want to know about our data set. Whether it's that the class, like more about the classes, more about the standard deviation, if it's a numerical like data set rather than like just like zeros and ones. If you give us a statistical deviation of like zeros and ones as far as labels go, you're not going to get a lot of important information. So representing the data in a way that makes sense is also important. Helps to have background information. Personally, I don't know what all this means, but that's because I'm not familiar with this like area of study. And that's something that I could look into, whether it's the reading related papers or talking to someone or going even to a research lab if I was curious about doing that. Seems like there's some discussion. Doesn't seem like there's much about it though, but it does seem like some people have used code in it. So if you wanted to, you could go look at how people have used the code or use the data set in their code. So more ways to see like who's using it and maybe why. Maybe it was just that it was a competition that they wanted to host or something like that. But as you can see, there's nothing really to say like it's simulated, which is what we're getting at. Is this data real? And you'll find that in biology, and like I think I forget if it's like protein genetics or enzymes specifically, but one of them has a really high rate of being simulated data instead of real data because they either haven't found it, can't like record it for some reason, or they're trying to anticipate it and like based on the surrounding knowledge, they've done their best to simulate a similar data set. There's a number of reasons why there's simulations, but depending on where you're at, simulated does not always mean you should use it. Kind of coming back to that point of, yeah, maybe it's better for a project and just learning like how do you load the data, how do you examine the data, etc. So let's go back and see. I was trying to see if I could find a simulated data set earlier. It used to be a little bit more common, but this is the one that I was able to pull up just by Googling it, where I don't know what this human array is, but it's genotyping, which tends to have that frequency of simulation. You can see that it has a pretty high Kaggle score as far as like usefulness. But again, critical doubt, good to have. Biology and genetics, never expected to update it, public domain, okay. But the data includes genotypes of a bajillion markers for 1,000 individuals. They come from a simulation. What does that mean? Well, if I knew more about Illumina, the human array, if we're simulating data, how do people simulate this data? What does that mean? What do they consider when they're simulating it, kind of thing. And so, as you can see, in theory, it's easy to create such data. It's just columns with values of 0, 1, and 2. That's a gross oversimplification, but fair. But what's important is the correlation structure that has been preserved here corresponding to the real one. Again, not having subject area knowledge, I just hone in on simulation. I'm like, what does that mean? Like, I really want to make sure that even if it's simulated, it's like not just garbage. And also, what's to say that even if I make a model for the simulation data, that it's going to be useful with quote unquote real world data. So those are some thoughts. I've rambled, but I also again want to check in. Do we have any questions? This seems like common sense, and yet people sometimes forget about it because they're just like, oh, data set, okay, like I can do whatever I want with it. Sure, but what does that mean? There's also more information about like who made it, what they did. You can see there's no DOI, which is like, if this hasn't been published yet, is it really scientific data? Is it just someone experimenting with simulation data, trying to get an idea of things? Seems like some people have downloaded it though. But yeah, so I'm gonna take a quick pause. We've gone around the world data set wise, but I want to check in and say like, what are some other ways that you might look at data sets and critically question them, whether they're useful for your project or not? Maybe you're just looking for something to start a project. Besides like thinking about the author, thinking about the source, thinking about, is it published data? How so? Even if it's published data, it could still be simulated. So what are some other questions you should have when looking for data sets? In the meantime, we can go ahead and check off these this links part. And then we'll get into the next bit. Perhaps no questions. Oh. Ooh, that's a great question. How do you deal with images that are extremely large? Spidey wanted to use images from a lunar orbiter, cool, but they were in the range of 700 to 800 megabytes. That's pretty big, and not surprising as far as space data or space or astronomy related data. That data is exceptionally large. Remember how I said petabytes? The black hole, like multiple hard drives. So there are a couple different ways. When you are perhaps working with a data set, there is a number of cloud-based solutions out there, like a cloud-hosted Jupyter Notebook, that might query a data set, whether it's that it's hosted online or some aspect, or maybe that if you are somehow able to download the whole data set, you downsample it. And this is a really common concept in computer vision. Oftentimes, huge, large, amazing quality images are downsampled as a way to reduce some processing time. And think about, like, okay, if we've downsampled this image to, say, an average size image, and we've lost that richness in the detail, can we still, for example, classify things? And so there's a lot of work actually that has been done in the computer vision space regarding downsampling and upsampling. Like, if you are given a, frankly, gross quality image, it's taken by a potato, can you upsample it? Which gets into more about like generative AI and like generative images and the things that have come out these days. Even though they use different patterns and different methods, there's many, many ways to tackle the problem. But you can see how like you could potentially ask like a generative AI to upsample an image, and it will fill in some details based on what it understands. So, for example, ChatGPT can, if you upload a file, an image file, you can tell it to give it like a caption or describe what's in the image, which is what it's kind of doing in that it's like looking at the photo and describing it. These large images are probably going to be downsampled when they get passed through the model because it's faster to process a smaller image. So, if you are into data science and like, you might find yourself using, I believe it's R, Python, namely like Pandas, OpenCV, etc. Those are very open source. And then I believe the new one is Julia. Not quite new, but like Julia and something else have been a common source for data scientists to come back and look at these large pieces of data. OpenCV and Pandas are really popular as far as like managing these large data sets. Pandas is incredibly efficient. You'll see it very commonly used. And yeah, so using images, you would dance. I typically downsize. Anytime I'm using anything image related, and I happen to like, if I can download a subset, maybe it's that I'm just training or just testing. Maybe I'll download 10 of those images instead of like the gigabytes or petabytes a data set might be. Downsample those by 50% or even 75% just to get a proof of concept of like, does my model kind of do the job? Coming back to that original question, of course. But then other ways is that data sets can be hosted online. And maybe it's that like Google hosts a number of data sets. You can use cloud computing to manage all of that. You are going to be paying for space, depending on where you store your data sets and how you're using things. So you now have two costs of compute and data set itself. So different ways that you can manage it. But generally with data sets, if they're not a CSV, and it's like image based, I will actually tend to download like a subset of images if I can, just to test like, can I even use these instead of downloading the whole image or the whole image gallery? I used to work with like an outdoor set of like camera images from around the world webcams or cameras that were like outdoor ones. We downsampled all of those because it was just too large and our model needed to process things faster. Sometimes it's a matter of matching the dimensions, etc. Chipotle, I love your name. I do like a good Chipotle. But as far as following up with other questions we should ask ourselves when we're looking at data sets, yes, absolutely. This is actually a later talking point, which is, so you want to create a data set. How do you ethically create it? But as far as and we'll come back to that, verifying how the data set was collected is actually quite hard. It's a little bit of a... trying to find the right words that doesn't actually hurt people, I guess. The way that data sets were created at the very beginning of computer vision, machine learning, AI, etc., wasn't exactly the most ethical. In fact, it was like really on purpose. And what I mean by that is that data that was collected or gathered was often perfect examples of things. Which today I would hope you think, no, the data set should be imperfect because that's how you better train a model, right? The thing is, all these different computer vision competitions, like I think at the time that I was involved, it was like AlexNet was like the thing that solved classification back then because it just blew people out of the water. But the thing is that data set was perfect. So perfect that if you gave it things that were imperfect, real world pictures of things, it would fail pretty badly. That 99% accuracy would drop significantly. And so verifying how data was collected is looking at the paper. There is a number of papers who said, we created this data set. Here's where we sourced from. But they don't actually say, like, did you include bad quote unquote data or did you delete it? Having clear transparency about how you put your data set together means for like a much more ethical author group, but also means that now your model is more realistic. So coming back to that like project versus real world application, think about self-driving cars. At the time that self-driving cars was coming out, there really wasn't a lot of data because everything was perfect, looking for that like 99% accuracy, right? And so when it came to driving cars, unfortunately, humans are not perfect. And so a lot of training was actually done in like GTA simulators. But what happens if you are, say, in the middle of nowhere and a deer runs in front of your car? Can you simulate that? And also, how often does that happen that you can collect that real world data in the first place? So you have some natural limitations to your data sets, being that there are some really, really rare opportunities for certain data that are obviously dangerous in some cases, that may impact the model itself. And so that's why we have things like the LiDAR detectors and a variety of things. Like spend some time looking at how self-driving cars like do the thing, basically, and spend some time thinking about their data sets. Like if you are like, let's like West Coast wise, like self-driving cars are on the West Coast. They're collecting all this data as they're driving. They're obviously autonomous. There's different levels of autonomousness and whatnot. And it's like, but how much data do they really have to collect to make it so that way they are what they are today? And like they're continually expanding because of course they're taking rides from people and whatnot. But yeah, verifying the data, how the data is collected, really important, but really actually quite hard if it's not published data. And even harder if they're not deliberately telling you, we did, because these reasons. Methodology, like distinctness and clarity, is hard in research because not many people do it. Like, unless you're specifically told, like, yeah, you should be, it's like chemistry, you should be able to follow the instructions and replicate the experiment. That makes for better reliability as far as research goes. And that's across the board. But not everything always relies on that. And then you have the whole qual versus quant paradigm issues where people are like, qual is better because you get more natural data and it's like interview data. And quant is like, that's not good enough. You need as many possible data sources as possible. And then there's a whole bunch of fighting there. Ask me how I know, but don't actually, please. That's a long conversation. But yes, excellent. Yeah, I made myself some tea after today in Global Hack Week. I was still pretty tired, so I wanted to make sure I had energy for the stream, so I have my tea now. But okay, so let's get into the next bit. Thank you for humoring me, chat. What are the rules with a data set, if any? So with Kaggle, there's probably not going to be anyone telling you, like, this is how you use the data set. You can't use it for XYZ. They're probably going to be open, do whatever you want. But that's assuming that the data set that has been added is allowed to be added there in the first place. So you might even back check before you just randomly downloading a Kaggle set and saying, like, hey, has this data set been authorized to be used anywhere else? Because there's always that risk. I would expect that the community is pretty good about catching those and not doing those, but sometimes people don't know better. Genuinely, some people just don't know better. And that's just the naivety of data science and related fields have exploded so quickly that not everyone is up to date on the nuances of how you should be ethical about it, because it's just not something that they actively think about because they simply haven't been taught or informed. And that's okay. It just means that some people have to do a bit more like knowledge searching and listening to some criticisms. But okay, so rules for the data set. I don't know that we're actually going to find one. But let's see. So I'm on the UK data service. Let's look at survey data and see. I'm skimming really quick just to make sure, because I can actually give you the background on this from a research standpoint. I just don't know if they'll tell us. Let's see. Many data sets, benefit, survey weights, accessing hierarchical data sets over time, survey bank resources, records. these are workshops. That's actually pretty cool. That's really useful. Okay. I am not seeing anyone mentioning, like in this specific one at least, restrictions on data sets, but they do exist. You do have to read for those. Let's see. So we'll make it a more of a theoretical chat then about that instead of having to provide examples. Some data sets can only be used for certain problems. That's not so much as a restriction, so much as a guideline, unless obviously stated otherwise. But depending on a license, which we saw some of the Kaggle datasets had licenses on them that really generally tell you how they're going to be used. And you'll see licenses similarly in like open source software, which is like, hey, open source software has like 3 or 4 different licenses that people can choose from, like the MIT, GNU, etc. That determine how the software can be used, whether collaborators or contributors can take that, like that software, etc. Datasets are kind of the same way. If you are a researcher and you have a private data set, you're not making that public. There's no way unless there are specific things built in to manage that. So from a real world example, in my PhD, I'm doing social sciences work, moving a little bit away from technology, but I'm not also. Make it make sense. So with my data, I had to get IRB approval. So I'm working with like interviews, but if I were, say, working with quantitative data, that survey data that I might collect, say, rate on a scale of 1 to 5, how much do I agree with this statement with like strongly disagree to strongly agree, for example. Maybe I might collect people's emails as a way to compensate them or like put them in a raffle. That email should never be published anywhere ever. In fact, IRB, or Institutional Review Board in the US, means that they should really not hurt humans. Like you're not allowed to hurt humans. Depending on the university and the corporation that may be involved with getting an IRB, does impact how the IRB is written. Everyone has different things that they're looking out for, but the general gist is the same. No hurt human or live animals or other aspects unless approved otherwise and showing how you will be ethical or diligent about it. But as far as like human produced data, no personally identifying information. So if you're working with a data set of survey data, let's say looking at that longitudinal survey, like social science work here, longitudinal surveys, a participant should have an ID that is not going to be identifiable in public. Maybe there is somewhere hidden in the private bowels of someone else's server or like database or whatever, the connection between the real world data or the real data that's been that's not anonymized and then the anonymized data. But generally speaking, that will actually be deleted at like after like a couple years versus the anonymized data might be kept for up to 10, 20, or forever, depending on the rulings. And so what that means is anonymized data means it should stay anonymous. So if you're looking at survey data and you're like, hey, like, I know who this is, or I could figure out who this is, bad data set, don't use it because it's violating a lot of human rights, human security, privacy, etc. And that's a risk. So another way to think about it is major violations are usually going to be when a research study emails its participants. Those should be in BCC, never in CC. You should never know who other participants in a research study are, as a participant, as a researcher, or other aspects. Only like a few people should know who's who, and if that's the case, they might need to be like one step removed to ensure a reduced risk of bias. So at this point, we're getting into like creating data sets. But I'm going to pause there, double check. Once again, any questions, feel free to post as we go. But I also want to talk about AI literacy. And if you've attended past streams of mine, you'll know that I'm like screaming from the mountaintops about this, which is think critically about what you ask ChatGPT or what you put in ChatGPT or Lensa or any other AIs. What that means is read the terms and conditions. And that's basically what the rules of the data set is also referring to. If there's terms and conditions, I know they're super exhausting, but it doesn't hurt to check it. Because especially with generative models, what are you giving them? So Lensa didn't really come under fire, but did have a lot of news articles by people who did read the terms and condition. When Lensa first came out, people were super excited because they're like, oh, I can take a picture of myself, put myself in any other like art style, or like change my appearance, all these things. The terms and condition here was that by providing your selfies, you were providing training data to this generative AI. On the one hand, great. On the other hand, kind of sus, because it's like, well, what if I wanted to use the model but not provide data? Can I opt out of that? What if you didn't read that? You have no idea where your data is now. So you'll see like people be like, but everybody already has my data. Yeah, but you should have a little more control about your data. So with ChatGPT, there's a number of security trainings out there now for various institutions, companies, etc., that basically say do not use AI in the workplace unless otherwise approved. And what will it be approved for is the critical question here, which is that if you use it for personal use on company time, on a company AI, or like whoever, that's kind of not great. What if you use ChatGPT to help with your work and you like paste code in? That's like private code you're probably giving to any data set. But I know that ChatGPT has certainly corrected some things and says like your questions may not be used for data sets or something like that. So again, think about where your data is going and how you yourself are contributing to a data set. And vice versa, what about the data sets that you're using? Were they collected ethically? Unsure sometimes. Transparency is pretty important. My favorite question! This is a good question. Spidey, you're coming up with some good stuff here. Actually, all of you have. There's been a couple people who've asked some pretty good stuff. Poorly documented data sets. So I told you about descriptive statistics, where you can start to get an idea of the trends of your data set. I did not tell you what happens if your data set sucks. And that can be for a variety of reasons, whether the data set created or in the process of being created was not consistent or did not have strict consistency rulings to make sure that data was entered a certain way, or just things happen. So whenever you work with a data set, regardless of whether it says like, oh, it's perfect, oh, like all the labels are there, or like, check the data yourself. Just check the data yourself. Because you want to confirm if you go and run things, like, are all the values as they're supposed to be? And chances are when you're making your own data set, it is not going to be consistent. The perfect data sets that you get have already undergone this process of being poorly documented or poorly like worked with or created, that the work of cleaning a data set is done because it's a perfect data set by then. But poorly documented data sets can mean a lot of things, whether it's that somebody didn't have time, or they are very imperfect, which can be a good thing, can be a problem. It might be that it's an open source data set, in which case maybe you can contribute to it and say like, hey, I've kind of figured out what's going on. Here's a pull request to better explain things if it's on like GitHub or something. Sometimes you can email the collaborator or the creator and be like, hey, can you give me some more background on this? But the reality is a lot of the hard work is just sifting through the data, sitting in it to figure out, what does it mean? What's going on? Can you use it? How unclean is the data? And by clean, I mean, are things formatted correctly? Or is there like a NA in a numerical column that you expected it to be only numerical, et cetera, et cetera. So sometimes you may have to clean a data set because nobody did it beforehand, which sucks, but it gets you the familiarity with the data set, which can actually help you improve it and potentially share back with a collaborator. Otherwise, it's kind of a good luck kind of thing, which sucks. You'll find that even in government data sets, they might still be poorly documented. It varies from country to country. I will say I truly believe that most of NASA's data sets are fairly well documented because they want people to use the data. Like, it's free, it's usable, like they're like, do stuff with it. But that could vary for other data sets like the WHO or otherwise. And whatnot. Yes, but you don't have to. If it's too much of a slog and it's detracting from your ability to do something, unless you're like required to like work on it or are paid to work on it, maybe there's a better data set out there. Maybe your contribution is documenting and fixing it, or maybe it's like that on purpose. There are a few of those. They do exist. Not a great answer. It depends, because that's most of AI, etc. Okay, so we've done rulings. We've done AI literacy, which is think critically about where your data is going. And is it the right answer? Probably not. How do you make it give you a better answer? Be more descriptive in your prompt engineering, yada, yada. All right, so the data set that you want does not exist. Now what? Or the data set sucks. Now what? The answer is, well, you can create it, or you can try again finding a different one. So let's say you have a data set. This comes back to Spidey's question, what if your data set sucks? And I'm generalizing, like not every data set sucks, but sometimes you have to go through and clean it. And by cleaning it, you can look for inconsistencies in the data that either should have been corrected or you can purposely correct for yourself. So let's say for a survey that I've created that is quantitative, I've allowed people to say not applicable in their answers on a scale of 1 to 5. And so not applicable is not a number, but the way that the data was collected says like not a number, or like or not applicable, and then there's like 5 3s and a whole bunch of other stuff. And so what I might do is I might do a replacement where in my paper that I'm publishing about this, I would say like, oh, we converted not applicable answers to a -1. And therefore, like either we skipped over it or didn't include it, or what have you, as like a different way to track it without losing that information. Some people will just delete it, which you will find that you are advised to almost rarely ever delete things. You're usually asked to like create an error list of numbers. -1 might be not applicable. -2 might be just no answer, because usually with these surveys, every question is optional. And so what happens if you have a not applicable and then a no answer? Those are two very different things. And so how do you distinguish those numerically? And so this is where labeling comes in as being incredibly important, because then you can go, okay, maybe I use a 7 because my max number was 5, and then I use the 7 and normalize it some other way, kind of thing. So there's plenty of different ways. As long as you track what you do, you are consistent with what you do. And then when you might publish this or in your documentation that you clarify, hey, the way this data set was cleaned is blah, 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 right? Cleaning actually helps you review the data, so you can start to see those trends, do those descriptive statistics if it's numerical. But you can start to see like, what does your data look like? What are you going to run into? What are the issues you might have later on when you're analyzing it, or you're using it elsewhere, or like, is it going to break your model? Is it going to break your program? Like, there was a lot of just pitch black images when I was doing computer vision. And it's because there's pitch black images because it's dark and there's no natural light. And then there's could not take the image because the camera was broken, which are two very different image files. One has a size and bytes and whatnot, and one has like 0 by 0 by 0 pixels or something like that. Very different. One would not break the model. One definitely broke the model. And so finding those, it's like, do you delete those? Do you add in like, and if it's this kind of thing, just chuck it, don't use it, or like just set it aside and say skip. Don't analyze this, but count how many of these we find, because then you don't have to analyze the broken image. You can just say like, there's X many broken images in here, and maybe your model already accounts for that. And then of course, critical questioning. Did you run against anything that made you go, that's weird? Whether it's your gut or your brain or other aspects that you're like, something just doesn't feel right, listen to those. Chances are you're right, or you're just sensitive about things, which will help you in the long run. Okay, so we've got about 10 minutes left. And in the last 5 minutes, I want to say that creating a data set on your own is very hard. But you can reverse your understanding of everything we've gone over, a bit roller coaster-y, mind you. It sounds like a typical workshop by me. Reversing it will help you create a data set. And so coming back around. So we have all these thoughts that we need to consider when we look at a data set. Let's say the data set exists. If we work our way backward, what is the data set that we want to create? And so this is a way of thinking about what you want as an output. This is advice I've gotten from one of my fellow researchers for a very long time. He said, if you're getting stuck in your research project, like, what are some of the end results you're wanting? And so let's say you've come up with a project idea and you're like, what kind of data do I need for that? Maybe you don't know how to search for it, or you've done some searches and you're not really finding it. The way to manage that is to think about the end result. Let's say you've come up with something saying like, hey, I really want to track trends in like the disappearance of shoe sizes in like America or something like that. This is something arbitrary. Like you're noticing that like shoe sizes from M to N are like only ever available. Is this a matter of stock? Is it a matter of the sizing available? Is it like a matter of product loss, etc.? So creating that is going to be tedious. But now you're like, okay, if I want to look at those trends, I'm expecting to find that like sizes 6 and below no longer for like adults does not exist. And sizes like 14 and above for adults does not exist either. You have to order online. And so you would start creating those observations. And so how would you notate those observations? And as you run into things like, hey, I've noticed like it does exist. How do I mark that? Hey, I've noticed that like a different size that like that from 7 to 13 exists, but there's no half sizes or something like that. How do you note those and how do you accommodate those errors that you find? Is it something that you actively track or that you clean later? And so we're working back and saying, okay, how do we identify the data? How do we track it? Like, are we only going to look at one specific store? Let's say if, what's it called? There's a shoe store that everybody used to go to, Payless. I think Payless doesn't exist anymore or something. It went bankrupt. Let's say Payless still existed. That's your local store. You're going to go there every single day and ask like the people at the desk for the latest like shipping manifest or something. You probably won't be able to get that. You might even be like, hey, I'm doing a study. Can I come into your store every day and like count boxes all day? I don't think they're going to care. But again, this is like make believe. And so you would walk through and you'd be like, okay, I'm seeing, 10 of this, 5 of this, whatever. And you're looking at different like styles, what have you. That is a very tedious process. You're going to need multiple people. What if you wanted to look at other stores? What if there's other ways to track things? And so you should ask yourself those questions. Alternatively, what's a proof of concept data set where you might say like, okay, my proof of concept is that I, individual me, will go to this very small shoe store that I am friends with them or something and talk to them and say, I want to track these things. Can you give me manifests about things? So that way I don't have to deal with like losing out before people have bought things, for example, et cetera, et cetera. And so maybe that's how you get your data set, in which case, like it's an Excel file, in which case you upload it and then you go clean it and then you go, okay, this is the context of the data set. This is like what happens, etc. So that's a very, very imagined situation. But it might also be taking images. So you could set up a camera on your house that is constantly taking video of something. Not much cleaning involved, but you'll have to go through and label it. And that's how you create meaning out of the data that you've collected. Your labeling could be timestamps. Let's say it's take an arbitrary, Ring doorbell. You want to download all that video, and you want to make your own classifier that looks for disturbances, which is a common feature of these doorbells. You want to do it yourself. And so you record all day, every day from that one angle. And you find all the time stamps for when disturbances happened. You now have labeled data. But what about if it says there's a disturbance and there wasn't actually a disturbance? That would be faulty, etc. So you're creating your first training data set. How much data is enough? The answer is it depends. Generally, the more data you have, the better. Depending on the model, though, it might affect how it's trained. If you're only looking at one angle, you now have a very perfect data set with regards to an angle. What if you moved your camera and it collected data at, a higher angle versus a lower angle versus a much lower angle? How does that change? And even then it might be, well, okay, that's one look into a street. What about us from the other side of the street? And so now you have multiple camera angles and now you have more data. But do you record the same data or not? Because then you need to have multiple cameras at the same time, or you have to move your camera at various times a day, which makes the data inconsistent because there's no longer matches. So you have to balance your process. You can also randomly generate data using just a random generator, and you can just throw it at things and go, what do you do? Just to get that practice of what does data look like? What could it look like? Whether it's random names or random numbers, and start to like do descriptive statistics and be like, is this truly random? There are so many things you can do. But what about ethics? So I talked a little about Lensa. I talked a little about ChatGPT. And I also talked about thinking critically about data sets. Ethics is important. Data should be collected with the consent of an individual before data collection happens, not during. And so I'm going to be a little pointed and say sometimes people collect data before they've gotten consent. How do you guarantee that those people are going to delete data when you don't get those consents? And so you'll see it on these videos of people stopping random people, like interviewing them in the street, you know, those like TikToks and whatnot. And so you have to ask, did they get consent to talk to these people? Was it that they were approached randomly first, recorded, like had this conversation, then we're like, can you do the thing? Or can you participate in this interview? And then they sign a consent? They've been recording the whole time. Is that really ethical data collection? Regardless of whether it being for a TikTok or otherwise. So thinking about the person you're interviewing or the data you're creating, is it respectful of others' personal information, of the things that they're giving you? And that's just human data. It's really hard to get consent from like pets and stuff, but like, again, think with common sense, with reasonability, etc. You might also have to consider government aspects. Like if you're taking photo, if let's say you're like pointing your camera at like an abandoned lot, turns out, oh my gosh, it's a security spot. Like, did you know that? Is that something you could have figured out? What if you have like the police knocking on your door because you've been recording this and they're like, you're not allowed to do that? Like, what if you accidentally capture your neighbor's backyard while doing this camera stuff? So thinking about how are you making the least disturbance while making sure that if there are humans involved, that their consent is captured before you do data collection, not after, because you still have to delete that. And how do you ensure that you've truly deleted it? They might not believe you. So yes, cleaning can always be done with Excel, Python. There are plenty of ways and resources out there. Web scraping is a contentious one. There's a time and place. Generally, if it's wrong, you're going to get a cease and desist if they notice you. Being respectful with your web scraping is important. Like you're not stealing traffic or monetary aspects. Let's say you could ask for permission from the website owner saying like, hey, can I scrape this data? Sometimes sites have APIs instead, and that's how you access their data, and that is ethical. But I will not give you any legal advice. I have not given you legal advice at any point in the stream. Web scraping can be not good, depending on the corporation behind them. Yeah. So that's going to be my very protected answer. Neither endorsing nor condoning it. Because even I've scraped data. Like I've gotten data from like the Shark Tracker app I did a long time ago. I just downloaded a current version of their JSON information. I did try to find an API. It wasn't the easiest thing to use. I just wanted like a sample of data. If I were continually scraping, that would be very bad. I'm like, I just want a proof of concept. I just wanted to show that I could do the thing. And I would say that that's okay because I'm not making money off of it. I'm not like hurting anybody. I was showing proof of concept of what you could do, not necessarily like encouraging it, etc. And so on and so forth. And like there is an official shark tracking app out there. I just wanted to do my own silly version because I thought it'd be funny. That's different. Where I'm again not gaining anything from it. So yeah. If you are taking the appropriate recommendations and using common sense, or you are asking permission, it can be ethical. But there's, what was it? I think it's a saying that they say about scientists, and frankly, they should say it about engineers, is that you should not ask, was it? Sometimes people will ask if they could, not if they should. And asking if you should is a good way to challenge, like, is this ethical? So, yeah. All right, we got less than a minute. So thank you for listening to my rambling about ethical AI, data sets, etc. I hope that now you are able to approach data sets differently. You will still be overwhelmed now that you have more questions. But hopefully you can think about, like, can I use this? How do I use this? Should I use this? And actually be able to go off and create a project that you can now talk about, like, these are the things I've considered, which paints you so much better than someone who just said, yeah, I use this data set. Okay, how did you come across that data set? How did you make sure that you honored yourself and the people around you? And that just makes for like better humanity, population, etc. So yeah, cool. I am going to share the websites at least that I have shared today in chat. Let's see how that goes. We're gonna find out because then you can go ahead and try and see if it sends. There we go. So there's plenty of websites there. Of course, there's Kaggle, which there will probably be some overlap on some of these data sets, to be honest. But check those sites out in your future projects. And of course, remember, just common sense. Ask if you should, not if you can or could. And yeah, and so I have a few more streams this week. So if you are looking to join me in more debugging aspects, we're going to be using ChatGPT. I promise it's ethical. It's more silly and like tongue-in-cheek, but feel free to join me in all of those. You can see those in the schedule, and stay tuned for Steven's stream, which is coming up right now, actually. Thanks, everyone. Have a good one.